Hello everyone, welcome back to the YouTube channel Devotion of Knowledge. In the previous couple of videos, we have completed our set container in which we studied normal set, unordered set, as well as ordered set. We also did implementation of all the three as well as problems for all the three set containers that we have studied. But now we are supposed to move forward in our STL playlist. So, in this video, we are going to understand about our next very interesting container, which is map container. You can also find it written as hash maps somewhere, but in C++, we just consider it as a map. In Java and other languages, it is written as hash map in the syntax. So whenever you find map or hash map, don't get confused. It's the same. Now, this container, you will find relatively easy if you understood set container in detail. Because if you understood the set container in detail, you might have good practice as well as idea how to access the elements of set using iterators, how it is implemented and all that things. So in map data structure, we won't be taking that much of videos or time as much we give in set. So let us first of all understand what is map. So map basically stores data in the form of key and value pair. Now, what is this key and value? This key and value means for each and every key, there will be some value stored into the map. I know it is not making any sense to you right now. So let us understand with example. It is somewhat similar to pair, but in pair, the multiple keys were present. For example, if we consider a case of pair data structure or the pair container that we have studied, there you were able to store 1A, 1B, 1C, 2D, 3E. You were able to store data like this. But in the case of map, you are not able to store data like this. For each and every key, unique key will be present. And for that particular unique key, a unique value will be present. For example, if you are willing to store 1 and A, then another one can't be present in the map. It stores unique key. And the value with respect to key is also unique. How? Let us understand the example. For example, if we have inserted 1 comma A in the map and you are again trying to store B with respect to 1, then it is not possible because as I said, it is a unique key as well as a value associated with the key is also unique. So it will erase this or it will update this A value to B. Okay. Now, similarly, like set maps also use red black trees in implementation in backend. Red black trees. Now, what are red black trees? They are basically self balancing binary search tree. We are not going into much detail because this is separately a very interesting topic, but this is the basic idea that you should have. They are self balancing binary search tree. Means it is having smaller value on left side and larger value on right side. So in map also, insertion time is log n, fetching the data log n, and also deletion of the data log n. Now I am not explaining why this log n because I have already explained this thing in the video of set container in which we have undergone or seen that why log n, because binary search trees store data in sorted form. So we will be uh, dividing the data or our search space in which we are searching a particular value. So map theory of map is enough. Now, what is the syntax of map? Means we will be also writing its implementation. Map uh, data type 1, data type 2, and name of the map that you want to keep. This is the syntax for the map data structure. Okay. Now, maps are mainly of three types. First one is normal map. Second one is unordered. And the third one is multi-map. Uh, we won't be going into much depth of multi-map because it is not much used in CP or DS anywhere. I will just give you some overview of multi-map, but we won't be going into the depth of multi-map. In this video, we will be covering normal map and unordered map. If you are following this series from the set data structure, then you would be knowing that in unordered set, the difference is time complexity because it works in O of one time complexity. While in normal map, it is almost similar to set data structure, so O of log n. Okay, so these are the main concepts that were associated with the map data structure. Now, let us see the implementation of the map data structure. First, let us make sure that recording is still going on. Okay, recording is still going on. So here is the our IDE VS Code. Now, as I told you, the syntax for writing map is this: map data type 1, data type 2. So if I want to store string as a key and integer as a value, so let us give a name n. Now there are multiple types to insert data in map. One is like m of ABC because the key is a string, so we will be writing here string because the value that whatever value we are supposed to store will be respect to the string. So m of ABC equal to 1, for example, AB equal to 2, and BC equal to 3. Now, as I told you, they are basically a pairs of key and value pairs. So map basically stores the pairs in the tree. So it is a tree like this. So it basically stores these are pairs, key value pair. So each and every entity is key value pair present into the map data structure. And sorting while inserting, as I told you, it takes log n time complexity. So it compares the key of each and every element, means in log n time complexity. As I told you, we divide search space in binary search, so like that. Another way is, as I told you, they are a kind of pair, so I can also insert map.insert what string a and value, for example 7, like this. It will be normal curved bracket like this. So if I run this program, okay, it is no, oh, we are not printing, so it is a iterator pointing to the map m. So as I told you, it is a pair, so to print the key, we will be writing it dot first, space between them, it dot second, and enter. Okay, so as you can see, it stores data in sorted form, and here key is our string. So the strings will be sorted in lexicographical order. So AB, ABC, and BC. As I told you, the key are unique. So if I store again 9 with respect to BC, but it won't be working because each and every key stores a unique value, means key is unique in the whole map. So here in terms of BC, it is 9 instead of 3 because it is updated. Now let me show you a very interesting thing. M of DF. I am writing nothing. Just I have written M of DF like this. Then what will be there in value? Yeah, 0. Means if it is integer, then it will automatically assign 0, and if it is string, it will automatically assign a null character, because here we have just written M of DF. We have not assigned any value, but as soon as you write M of any particular key, the compiler or the C++ will automatically assign 0 if it is integer, or null value if it is a string data structure or character. So yeah, this was enough. And also unordered map. Okay, let us declare it as unordered map. Okay, now let us run the code. As you can see, it is completely random order because unordered map uses hash table similarly like unordered set, and data is in sorted form. But here, as I told you, the difference is in time complexity because we can access the data in O of 1, means as far as MO times analysis we are doing, it is constant time complexity. So this is enough for the map data structure. You can also delete data structure by writing m dot erase. I want to delete this data of df. So you are supposed to write key in the erase function and it will get deleted. So we can see df was there, but now df is deleted. You can also m dot find function. We can also search for any particular value. It will return iterator. So m dot erase. Okay, here let us store auto it equal to it. I think it will work. Okay, see here we are finding BC and it will return us a iterator. So I am storing it in the IT, and now I am passing iterator as an argument in m.erase function. So it will erase the particular pair which contains BC as the key. So now as you can see, BC was there previously, but now it is not part of our set. So I think it is enough for this video. And see, oh, okay, I forgot to explain you this. The complexity won't be always log n because, for example, let us consider a case we are using map of string. Is in the case we have seen the implementation like this. So if I am passing a string of a very large value, for example, string of size, let us say 10 raised to 5. So in the tree, I will be having this string equal to the length of 10 raised to 5. So this will be tree, for example, like this. Okay. Now, when I am trying to insert any new value or any new pair, as I told you, log n time will be taken because each and every key will be compared with, means log n times. So all of these are 10 raised to 5. Let us say 10 raised to 5, 10 raised to 5. Each and every string is of 10 raised to 5 length. 10 raised to 5, 10 raised to 5, 10 raised to 5. Okay. So now this one is also 10 raised to 5. So whenever I am trying to insert this new pair, This string will be compared to this, so it will take 10 raised to 5 time complexity. Okay, then if it is favorable on this side, it will be compared with this and then this. So here log n time complexity is there, but log n is done for how much times? 10 raised to 5, 10 raised to 5, 10 raised to 5. So it is n log n, or we can say size of string star log n. This will be a real time complexity because here size of string is 10 raised to 5. So it will be comparing with this and log n time because we are dividing the search space into half. So log n for dividing the search space into half, and on each iteration we will be comparing with this the whole large string that we are having as a key in the map. So it will be size of string star log n. I hope this thing makes sense to you. So don't get confused each and every time that it is log n. Sometimes if you are using some large containers like string, in this case large strings, then it will be a considerable amount of time complexity. I hope guys this was enough for map data structure. In the next video we will be solving a very basic, or you can say standard problem on map data structure container. It will be of code forces. Let me again tell you, it will be problem named registration system. It is 1300 rated problem, but 1300 I know it's a good rating, but it's a really basic problem which everyone generally solves with the while understanding map data structure. So we will be solving that question, and then we will be finish this map data structure, and then we'll move forward to learn the new concepts. So I think this is enough for this video. We will meet in the next video. Till then, keep learning, keep hardworking. Thank you very much.